Question 18 gives you the equation x plus y is equal to k, and they say it's tangent to y equals x squared plus 3x plus 1, okay? So we kind of need to visualize, they want us to find the value of k here that would make this tangent to that. So one of the reasons we have you take such a challenging honors geometry program is the fact that visualization is unbelievably important on the AP exam. And so I would say for probably half the problems, I make some kind of a quick sketch. And it doesn't have to be dead on, but it has to give you an idea of what's going on. So here we've got some kind of a parabola, okay? And I have absolutely no idea where it is, but you know, maybe the parabola is doing this sort of thing. And I've got, notice that's a straight line, okay? So they're telling me that's a tangent line. That line's gonna come in and it's tangent to the curve at some point. So you know, it's doing that kind of thing. Okay, so here's my y equals x squared plus 3x plus 1, and here's my x plus y equals k. By the way, I'm going to rewrite that in slope-intercept form. That's y equals, I can subtract x from both sides, negative x plus k, okay? And by the way, that tells me something. It tells me that the slope is negative 1. We don't know what the y-intercept is, but the slope is negative 1, and you'll see actually I knew that already because I made a sketch of it. But anyway, so just a little bit of an idea of what's going on here. So if you think about what's going on here, for a line to be tangent to a curve, it's got to do two things. It's got to pass through that point on the curve. So we might have to figure out what's the intersection point between these two equations. Might have to set the two equations equal. But the second thing, if it's going to be tangent, the slope of the line has to be the same as the slope of the curve at that point, okay? And so we already know the slope of the line. The slope of the line is negative 1. We got that from the original equation. So we just need this to have a slope of negative 1 at the same point, okay? Well, remember, a derivative is the slope of a curve at a point. So the derivative here is y prime equals 2x plus 3, okay? We need the slope to be negative 1, so we'll set the derivative equal to negative 1, and if you solve here, you get negative 4 is equal to 2x. X is going to be negative 2, okay? So that tells us, if we're trying to draw a picture here, at the point where x is equal to negative 2, this tangent line is going to be tangent to that curve, okay? Now, we need to figure out what this point is because we already knew what the slope was. We need to know what k is going to be. Well, so at this point, I should be able to put negative 2 into this function and find out what the y coordinate is, and we can get the coordinate of that point. So I'm just filling in things as I think to look for them. All right, so negative 2 squared is 4. Plus 3 times negative 2, that's negative 6, plus 1. So let's see, negative 2 plus 1 is negative 1. So it looks like that's the point negative 2, negative 1, okay? So it's got to be the same point on the straight line, too. When I put negative 2 in for x, I want to get back a negative 1 for y. So we've got negative 1 equals positive 2 plus k, okay? If you solve that, k would be negative 3. And so that would be the equation. Negative x minus 3 would be the line that would be that would hit that at that point. And it looks like that's choice A on number 18. So great question.